This LOS is solve time value of money problems for different frequencies of compounding. Okay, this is compounding for different frequencies. So again, I have a little table here at the bottom. We're going to look at just an example using 1 year. So n is going to equal 1 in this example. So starting at the top, we have the algebraic formula that should be familiar to us now. It's similar to what we saw in the last LOS. The future value equals the present value times 1 plus the interest rate divided by m. M is the number of compounding periods per year, to the power of mn. And so n was the number of years. So in the bottom, our example here at the bottom, we're just doing n equals 1 again. So I'm not going to run through all the examples, 8% for the annual, semi-annual, quarter, monthly, daily. Let's just pick on this one here, the quarterly. So, and here we're going to look at the value of just $1. We're doing $1. So it's the future value equals the present value times 1 plus 8% divided by 4, because it's quarterly, to the power of 4 times 1. So we can see that we're going to get $1.08, and so the effective rate on quarterly is 8.2432. So again, if we want to do on the calculator using the algebra, let's just do it again. 0.08% divided by 4 quarterly plus 1, y to the x, just 4 because we're doing just 1 year, 4 times 1, minus 1 times 100, and you can see our effective annual yield 8.24432, okay, which is there. Also, you can still use your interest rate conversion. So remember, second interest rate conversion, nominal interest rate is 8, hit enter, arrow up. It's 4 quarterly, hit enter, arrow up, hit compute, 8.24322. So it's exactly the same. So there, this slide is nothing really new. It's very similar to what we did in the last LOS. We have the algebra that we can do. We can use the interest rate conversion, or down here, which is just showing you all the steps in terms of, here's the interest rate nominal divided by the m, mn, which is the, again, n was 1, and then the future value of the $1. Okay? The very last thing here, though, we have the continuous compounding. This is going to be new, and we're going to see this quite a bit in the next few slides. So the continuous compounding, I'm going to show you how to do the keystrokes on continuous. I wrote the keystrokes here for you. So it's going to be 0.08, 8%, and then we're going to hit the second key, e to the x, minus 1, okay, times 100, and you're going to see that the continuous compounding, 8.328711, so it's just a little bit more than the daily. So the continuous and the daily are often very similar, but they're not exact. Okay, here we're just going to look at a little example. Suppose your bank offers you a CD, certificate of deposit, with a 2-year maturity, a stated annual interest rate of 8%, compounded quarterly, and a feature allowing reinvestment of the interest, so it's compounding at the same interest rate. You decide to invest $10,000. What will the CD be worth at maturity? Okay, so you can see it's a 2-year maturity, and it's compounding quarterly, so that our number of periods is going to be 8, correct? That's our n, 2 years, and our m is 4 quarterly. So n times n is going to be 8, okay? Now our interest rate is going to be 8%, but it's compounding quarterly, so the interest rate per period is going to be the 2%. So again, you can do it using the algebra. 10,000 times 1 plus 0.08 divided by 4 to the power of 8. So that equals 10,000 times 1.02 to the power of 8. We're going to get 11,716 and 59 cents. So again, let's just do that quickly on the calculator again. It's going to be 0.08 divided by 4 quarterly plus 1. Now you got to be careful here. It's y to the x 8 because it's quarterly for 2 years. And then we're going to multiply that by our original $10,000. Well, I went too far. And 11,716.59381. Fantastic. Now the holding period yield, you can see effective yield, holding period yield is going to be 17.16594%. Okay, and the way we do that is we just run that same formula that we saw the last LOS. It's going to be 0.08 divided by 4 plus 1 y to the x 8 minus 1 times by 100, and that's going to be 17.16594. Okay, and you can just prove that to yourself because the holding period, it's the ending minus the beginning divided by the beginning times 100, 17.16594%. So I just want to show you, if you really hate algebra and the old school, you forgot your calculator, you just have your phone, then you know, listen, this is not too much. It's only 8. It's only 8 periods. You started with 10,000. You know that the interest rate is 8% quarterly, so it's 2% per period, and it's for 8 periods. You could do 10,000 times 1.02 once, twice, 3, 4, 5, 6, 7, 8. And if you do that, you're going to get the exact same number. That's the way that I sometimes teach it to the non-algebra, non-calculator caring people. And it's really easy. It's just 10,000 times 1.02, 8 times, and you're going to get the same answer. Okay, another way you can solve this same problem, though, is just using the time value of money functionality on the calculator. So here we have N, IY, PV, payment, and the future value. So in this case, we can see that the compounding periods, it's going to be quarterly. So I have to do second periods per year 4. Oh, I had it on daily here before. So I'm going to hit 4 and I'm going to hit enter. So we have to set the parameter to the question. Okay. And also we want to be in the ending mode. We're in the ending mode. We're not in beginning mode. So we know that this was for 2 years. So we can do 2 second, and n is going to give us n equals 8. Or you could have just typed 8 and then n. But you can also do 2 years, second, and n, because you set the parameter py equals 4, you're going to get the same number. So n equals 8. The interest rate is 8%, so 8 IY. We don't adjust it because we already set up the parameter as quarterly. So we put in the 8%. We put in the nominal rate. Okay. The present value is 10,000, so that's 10,000 going out of our pocket. 10,000 negative PV. One has to be negative, one has to be positive. Okay. There's 0 payments, and then I'm going to compute the future value, and I get that 17,716 and 59 cents, exactly the same as we did using the algebra. And again, the holding period yield, ending minus beginning divided by beginning times 100. It's our 17.16%. A quick little practice question for you. The value in 6 years of 75,000 invested today at a stated annual interest of 7% compounded quarterly is closest to A, 112,555, B, 113,300, or C, 113,733. Okay, the answer is C, 113,733. On the left-hand side, I just reminded you the algebra, but I'm not going to work my way through it. It's a lot easier to do it on the calculator, okay? So again, using the time value of money. So I'm just going to see this is done quarterly. So second, PY, second, PY, yeah, it's still set at quarterly, so that's fine, no problems. So the N, we have to see it's 6 years compounded quarterly. So again, you can hit 6, the years, and then just do second and N, you're going to get the 24. That's an easier and safer way to do it, I believe. Okay. The present value is going to be 75,000 out of your pocket. So 75,000, I'm going to do the plus minus key because it's money out of our pocket. That's our present value. The interest rate is 7%. So it's 7 IY. Again, we don't adjust it because we've already set up the parameter PY equals 4. We put in that 7%. That's the way that I prefer to solve the problems. Again, there's no payment, and we're going to simply compute the future value, 113,733.20. 113,733.21 rounding. The answer is C. Okay, another quick practice problem. The manager of a Canadian pension fund knows that the fund must make a lump sum payment of $5 million 10 years from now. So that's in the future. $5 million must be made. Okay. She wants to invest the amount today in a GIC so that it'll grow to the required amount. That's going to be the future value, $5 million 10 years from now. The current interest rate on the GIC is 6% a year, compounded monthly. How much should she invest today in the GIC? So we want to know how much today. That's a present value question. Okay, here's the solution. On the left-hand side, I've got the algebra. I don't want to spend a lot of time going through it because it's really easy to do on the calculator. But nevertheless, there's the algebra. A little bit of a difference here. It's a present value question. So the present value equals the future value times 1 plus the interest rate divided by the frequency of compounding. But because it's the present value, we're y to the x, we're putting it to the negative mm. You see there? There's a negative there. So again, here's the algebra on the left-hand side. The present value equals 5 million times 1 plus the 6% compounded monthly, but it's to the power of negative 120, okay? So I even gave you the keystrokes down here for the people that love the algebra. 0.06 divided by 12 equals plus 1, y to the x, 120. Hit the plus minus key because it's negative, equals times the 5 million. You'll get the 2.748 million, okay? But to do it on the calculator, it's a lot easier. So we're compounding monthly, so we're going to do second PY. Remember, we had it on quarterly from the last question. So we're going to hit 12, and we're going to hit enter. So now we're set up for our monthly, okay? So then it's for 10 years, so we can do 10 second NN. So it's N equals 120, which is 10 years times monthly, 120. Interest rate is 6%, 6 IY. As I said, no adjustments there, because we've already changed our parameter. There's no payments, okay? The future value that we want this 5 million, and I'm going to keep it positive in the future. So in this case, we're just going to compute the present value, and it's 2.748163.67. So $2,748,163.67, okay? So whether you like the algebra, that's fine, but I think it's a lot easier to use the time value of money functionality on the calculator. Okay, I put this question in. You have to think a little bit and perhaps do more than one calculation in the 90 seconds. So a money manager has $1 million to invest for 1 year. She's identified 3 alternative 1-year certificates. Which CD has the highest effective annual rate? So you can see CD1 is compounding monthly, and the annual interest rate nominal is 7.82. CD2 is quarterly, and the nominal interest rate is 8%. And the last one is compounding continuously, and the interest rate is 7.95%. So which one has the highest effective annual rate? 1, 2, or 3? Okay, you can see here on the left-hand side, I've got the algebra, and including the keystrokes to run it continuously. And the correct answer is going to be, it's the continuously. So the correct answer is CD3. And but what I did, because for small amounts and short periods of time, what I did is I just solved it using the time value of money functionality. If I couldn't remember the keystrokes for the continuous compounding, which happens to some students, remember, I'm looking here at monthly, quarterly, or continuously. If I can't remember exactly how to do the keystrokes for the continuously, the second e to the x, etc., I can maybe use 365 days, daily compounding, as a proxy, because we know for small amounts, short periods of time, the result is going to be very, very quick. So again, this is going back to using our interest rate conversion functionality. So I'm going to do second interest rate conversion. The first one is going to nominal interest rate 7.82, so 7.82. I'm going to hit enter. I'm going to arrow up, and it's compounding monthly, so that's 12. I'm going to hit enter, arrow up, and I'm going to hit compute, and I'm going to have 8.01646. So that's right, I've got that there, 8.10646. And now, again, I'll show you this is really easy than doing the algebra. I can just arrow back down to my nominal interest rate. I'm going to hit 8 for my second one, CD2, hit enter, arrow up, that's quarterly, 4, enter, arrow up, hit compute again, 8.24. Aha, 8.24322, so now that's higher. Now I know, as I said, if I do daily, I know that continuously would be a little bit higher actually. So let me just do, I'm going to arrow down, and I'm going to do the nominal interest rate is 7.95. I'm going to hit enter. Sorry, my keystrokes there. 7.95, enter, and I'm going to arrow up, and that's continuously. As I said, as a proxy, I'm just going to use 365, hit enter, arrow up, and I'm going to hit compute, 8.27362. Aha, 8.27362. CD3 on daily is giving me the highest rate. So I know continuously is going to be a little bit higher, so it has to be CD3. But if you want to remember the exact keystrokes, it would be 0.0795. I'm going to do second e to the x, right? Minus 1 equals, and then times 100. And so for the continuous compounding, you can see 8.27456. So just a little bit higher than the 8.27362. So that's a little trick. For small amounts, short periods of time, if you're panicked on the continuous compounding, not getting it, then sometimes you can use a proxy, use the daily, you're going to be close enough. Okay, here's a little bit more practice on the continuous compounding. So we've got the algebraic formula at the top. But let's look at the example, and here I give you the exact keystrokes. Suppose you have 10,000 investment, will earn 8% compounded continuously for 2 years. What's the future value on that? Okay, so here I've got the keystrokes, starting with the first bullet. It's going to be 0.08 times 8% times the 2 years. I'm going to hit my equal sign. Then I'm going to do my second e to the x, okay, times 10,000 equals 11,735.10871. Okay, so as I said here, a quick way to check, just a reality check, is that if I just ran it using 365 again, so second periods per year, 365 daily, enter. So I know that n is going to be 2 years times, it's going to be 2 second nn, so it's going to be 730 because it's for 2 years. Interest rate is 8%, 8 IY, okay. Present value is 10,000, going to make it negative out of my pocket, PV. No payment, and I'm going to compute the future value, 11,734.02. You can see I'm just within 26 cents actually. So again, for small amounts, short periods of time, using 365 daily compounding gives us an answer that's quite close to our continuous compounding, because sometimes students have a hard time remembering the keystrokes. 0.08 times 2 equals second e to the x, and then multiplied by that present value amount, 10,000, and that's how you do it. So here's a good little practice problem that would be typical of something that you might see on the CFA. So an investor deposits £2,000 into an account that pays continuously with an interest rate of 6%, okay? The value of the account at the end of 4 years is closest to A, £2,525, £2,542, or C, £2,854. Okay, the correct answer is B. So let's just do it on the calculator using the proper keystrokes first. So again, it's 6% for 4 years and continuously compounding. So 0.06 times by that 4 years. Don't forget to hit the equal sign. Then second e to the x, and then we just multiply by that 2,000 pounds that we're going to invest. Hit equals 2542.498. So it works. And again, as I said, if you want to just check if you couldn't remember that, and this was a question on the exam, I think that you could still get it right if you did the second and kept it in the daily. So we know that it was 2,000 out of our pocket is our present value. Okay. Interest rate 6% IOI. It's for 4 years, so 4, second, and N. Okay. 0 payment, and compute the future value 2542.448. So it gives us an answer that's very similar. So again, I said works for smaller amounts, but be careful, because we're going to see here in the next and final practice question that you need to be a little bit careful, and you have to understand how to compute the continuously compounding, because, well, you'll see why. Okay, so here's a question. Given a €1 million investment for 4 years and a stated interest rate of 3% compounded continuously, the difference in its interest earnings compared with the same investment compounded daily is closest A, €1, B, €6, or C, €455. So in this, there's no choice, folks. You can't use the little method of compounding daily because they want you to compare it against the compounded continuously. Okay, the correct answer here is B, folks. So let's just do it the proper way on the calculator first, the continuously compounding. So we know it's 3%, and it's going to be 3%, and it's for 4 years. Okay, so it's 0.03 times by 4. Don't forget your equals. Second, e to the x. Multiply that by our €1 million. 1, 1, 2, 3, 1, 2, 3, and we're going to hit equals. And so we're going to get 1,127,496.852. That'll be our future value. Okay. Now we need to compare it versus the daily compounding, and that should be so easy for you by now. Second PY, just check, it's still in the daily mode. So that's going to be €1 million goes out of our pocket, so I'll make that a negative present value. The interest rate is 3%, 3 IOI, and it's for 4 years, 4, second, and N, okay? No payments, and we're going to compute the future value, and I'm getting 1,127,491.292. So I can see I don't even really need to do it on my calculator. I can see it's 5, it's around 5 and change. So A, it can't be 1. It's not €1 and it's not 455. So it's 6. But if I just want to hit equals there and I subtract it just to finish it off, the 1,127,496.852, the difference is €5.56. So it's closest to B, 5.56 difference, closest to B, 6. So if you get, if you forgot the keystrokes, you might have guessed A, but no, because I said small amounts, short periods of time, there's not much different. But on €1 million for 4 years, we have a difference of about €6. So in this question, unless you could remember how to do the continuously compounding, if you forgot, then you'd be guessing, and that wouldn't be great. And that's the end of this LOS. Thank you.